Welcome back to Atomo Tutorials, and in this video we will be looking at the modern periodic table. So the periodic table is a table displaying all of the known chemical elements. It places each element in order of increasing atomic number. So if you look at the sort of guide for the nuclear symbol, what we have is the relative atomic mass, which we've looked over, and we have the atomic number, which is the number of protons that the element contains. As we go from one element to the next on each row, the atomic number increases by 1 each time, and then the new row is started underneath it. So we're going from hydrogen to helium, that's 1 proton to 2 protons, lithium, beryllium, 3, 4, 5, 6, 7, and so on, all throughout the table. And these rows are referred to as periods. Now, when we arrange elements like this in rows, what happens is we get these columns which appear, and these columns, these vertical arrangements, numbered 1, 2, 3, and so on, are known as groups. So we have groups, group 1, group 2, group 3, 4, 5, 6, 7, all the way to group 0. And it turns out that the elements in each of these columns or each of these groups tend to have similar chemical properties. And by that I mean the way in which they react through the transfer of electrons tends to be the same, as you will see when we look at electronic configuration. So we're going to talk about everything to do with electrons and electron shells and how all that links to how the table is arranged, and it will all make sense. But one final thing that I want to look at in this video is how the periodic table is divided into sections of metal and non-metal elements. So if we ignore the different colors of the nuclear symbols, the elements on the right side of this red line, along with hydrogen, are non-metals. While the rest of the elements on the left-hand side of this red line, which is the majority of them, are metals. And this distinction is especially important when looking at ions and how different ions are formed with metal ions and non-metal ions and ionic bonding. But for now, just try to be familiar with this separation. I'll just correct that. There we go. Now that makes sense.